All right, let's talk about normal distribution. So on page 250 of your book, there are the rules around normal distribution. And I think one of the biggest things to think about when you think about normal distribution is that the rules emphasize symmetry. All right, so I've drawn a normal distribution. I've tried to do as best I can to scale. And what I'd like to do is just to talk about a problem. I want to actually work a normal distribution problem. These notes, the videos that I'm providing, are to supplement what is already in your book. And we talked about z-score and how z-score is a measure for what? Z-score is a measure for standard deviation, right? So z-score, actually I made it right, this is z-score, right, is a measure for standard deviation from the mean. I'm just gonna abbreviate standard deviation. Which we are calling mu, right? And we know that the mean is located right smack dab in the middle of this distribution. So if we were to talk about one of the instances that we're given in your book gives us a situation when they tell us they want to know how long will a customer wait in line, right? If they're telling us that mu is equal to 12, right? That the wait time averages 12 minutes, right? And they're telling us that the standard deviation is 3 minutes, right? And so we'll say this mu is 12. The standard deviation is 3. And they want to know what is the probability that x is going to be less than or equal to 14. So what's the probability that someone is going to wait on the phone 14 minutes or less, right? So in order to solve this problem, we solve it by solving for z. So z is equal to, and x minus mu, 14 minus 12, right, divided by 3. And then that gives us 2 over 3, which is equal to 0.6. We're going to do 4. We're going to round to 4 decimal places, right? So this is our z-score. This is not the probability. And if you look in your book on page 353, it gives you a table. And the way we look this up in the table is that we look for the first digit of z on the left-hand side, and then we look for the second digit of z on the at the very, very top. And then when we go over, 0.07 from 0.6, right, we know that, the probability of x is less than or equal to 14. It's going to be equal to the probability of z being less than or equal to 0.6667, right? And that's going to be 0.7486, looking that up in the table that's in your book on page 253. I don't have a means of showing you how to look it up in the table. I apologize. But the book gives very, very good instructions on how you look up the z-score. So the main thing to know and understand here, and I'm going to come back in a secondary video and talk about a couple other things, is that when you are finding the probability, the z-score, you find the z-score gives you the probability. So you have to look up the z-score. To look up z-score to find the probability. Okay, I hope this is helpful, and I'll be back in a video in a couple minutes to talk about just some of the nuances of the z-score and what that means. All right.